Finally, I'd like to talk about a general method for factoring polynomials, which is outlined in your book on page 63, and then take one example. So when you're faced with a polynomial, you're asked to factor it. The first thing you should do is factor out the greatest common factor. So look at every term in the polynomial. If there are factors common to each term, then you need to factor those out. Once you've done that, you might be done after one step, but you should always check what you're left with. The factors, once you have factored out the greatest common factor, and if there are two terms remaining, for example, you have 5x minus 4, something, or x squared minus 4, that would fit a pattern. So if you have two terms, you should look for one of our patterns. We have the difference of two squares, we have the sum of two cubes, and we have the difference of two cubes. If it fits one of those patterns, factor it out. If it has three terms, then we should use the trinomial method that we've had several examples for. Then finally, once you've done 1 and 2, you should look at each of the factors that you've gotten and see if you can factor them further. Many times you'll get a factor that you'll be able to break down into other factors, and so you want to do that. So it's kind of a repeating method until you get down to factors that can't be broken down anymore. Let's take an example. This is checkpoint 11 in the book. It's a trinomial, but the first thing we should try and see, and again, I always try this first. Let's look at and see if we can take out some common factors. So if we look at the first term, we have 3 and x's. Second term, it's got a couple x's, so it has that in common. 3 is also a factor of 30. So far we have 3 and x squared as common factors. Let's look at the third term. 3 is the only possible factor, number factor they might have in common. And 3 actually is a factor of 75. 25 times 3 is 75. So all three terms have 3 in common. So we'll factor that out. And then the x's as well. There's 3 x's, 2, and then 1. Every 1 has at least 1 x, so we should be able to factor out a 3x. So let's take that out. Now we need to put another trinomial in here such that when we multiply it, we would get this back. The first term is going to come from putting an x squared there, because 3x times x squared gives you 3x cubed. Second term, we'll have to put a 10 in order to get a 30. 3 times 10 is 30. And we also are going to need another x. So minus 10x. And again, if you multiply these two, you will get minus 30x squared. And then for the third term, in order to get 75, we're going to need 25. We already have an x, so we're not going to need more x's, so that would be factoring 3x. The greatest common factor is 3x. We took it out. This cannot be factored. 3 and x, those are as far as you can go. But you should check and see if the this factor that we ended up with, we can factor further. It's a trinomial, so let's try one of our trinomial methods on it, or the trinomial method. It's a trinomial. Let's try to factor it into two binomials. I'll put the parentheses in. The leading coefficient is 1, so this would have to be, in this case, it's variables x, and x. Over here, we could use 25 and 1. Actually, it'd have to be negative, though, wouldn't they, in order to get a negative here. So negative, in order to get a positive here, a negative there, we could use negative 25, or negative 1 and negative 25. Or we could use negative 5 and negative 5. I think if you look at it in your head, you can see this one won't work. This one should. Let's put minus 5 and minus 5. We're definitely going to get our x squared. We're going to get our plus 25. The middle term, minus 5x, minus another 5x will give you your negative 10x. X minus 5 and x minus 5 cannot be broken down any further, so this is factored as far as it'll go. Many times, just to write a little bit more concisely, we'll put this together and write it as, we have two factors of x minus 5, we'll write it as x minus 5 squared. So this might be the preferred way to write it, but they're both okay.